Welcome to ArcGIS Dashboards, Designing Effective Dashboards. My name is David Nineheis.
And my name is Subin Choi. We're both product engineers on the development team in Redlands, and we're glad to have you here today.
Have you ever been frustrated with a dashboard or had an argument about it? Perhaps you're a manager, executive, or operator using dashboards. Have you ever had to use one that was poorly designed? Perhaps it was full of information, yet didn't provide context to what you were seeing. Or worse, maybe an issue slipped right past you because it wasn't apparent on the dashboard. Whose fault was it?
Perhaps you're the one being asked to build a dashboard. Have you ever felt it is impossible to show the plethora of information requested on a single dashboard? Have you ever felt you simply can't create the visualization they want because of how the data is structured or because it spans multiple data sets? Or have you felt that what they're asking for simply is not a dashboard? If any of these resonate with you, then you're in the right place.
In this completely refreshed session, we'll look at dashboard best practices through the lens of different types of dashboards and cover some advanced techniques for creating visualizations. After that, we'll touch on some additional topics such as color considerations, mobile design, how dashboards may have to evolve with time, and how to ensure that they scale well. Now, you don't need any prior experience creating dashboards. However, it will certainly aid in understanding how to implement some of the ideas shown. To kick us off, I'll hand it over to Subin to talk about some tips for improving dashboards.
Thanks, Dave. And before I begin, I wanted to clarify that none of the dashboards I'll be demoing today are official dashboards. Dashboards are great for visualizing and breaking down large data sets. Here is a dashboard that is using 311 requests submitted to the city of Pittsburgh since early 2015 and has accumulated close to 500,000 requests to date. As you can see, the dashboard displays data both spatially through the map and temporally through the serial charts on the bottom left. It also provides various breakdowns of requests by status, request origin, departments, and categories. While the dashboard provides useful information, let's consider ways to improve it. Immediately, what do you notice? For me, it's the colors. We have a lot of them competing for our attention. Where do we start? What do the colors mean? Or are they meaningful at all? We can certainly leverage color to visualize data effectively, but the colors in the dashboard are more confusing than they are intuitive. Then we have this pie chart that is split into way too many categories, to the point it's not even legible. Lastly, what do all these numbers mean? Is it considered a high number? Are we looking at requests from a particular time period? What is the general context here? Without a defined time frame, these numbers don't have too much meaning. Let's start by taming the colors back a little bit. We're going to remove the background color, which was initially used for branding purposes. And we're simply going to replace the branding with a logo in the header. While we're at it, let's remove some of the other colors as well, except for the color used to distinguish the request status so that it aligns with the symbols rendered in our map. We can simplify the color on this bar chart, for example. And let's also reconsider how we might improve these two pie charts. What we will do is to replace them with elements that are better suited to display the given information. We can use an indicator to simply display the count of distinct request types submitted, and use a bar chart to better communicate where most of the requests are coming through. Now let's hop over to the next improved dashboard. As you can see, this way there are fewer visual distractions. Anytime a color is applied, we can see that it's consistent across visualizations, like how blue represents open requests and purple represents closed requests. and the information is easier to understand even at a glance. As you can see, we've also added a date selector to put the dashboard into context. And we can set it to filter other contents of the dashboard for a specific time period. Back to you, Dave.
Thanks, Subin. Better, right? The dashboard is more focused and easier to interpret. It's perfect for a general audience, such as citizens. For a more specific audience, however, such as the 311 Programs Operations Center or the mayor's office, there may be a few questions it still can't answer. Were there any problems to be aware of? How did the numbers look? Were there any changes that were concerning or interesting? We couldn't really tell. What if we wanted to dig into the data and slice it in different ways to investigate something? Now, before we get into that, let's consider some core principles that will guide us in creating effective dashboards. Good dashboards grab your attention to where it's needed. They communicate information that was previously hidden in the data at a glance. They make it easy to spot what's most important through elevating visualizations and metrics through layout placement and color choice. But wait, what is a dashboard? Common understandings of the term dashboard include a single screen of information and a display with charts on it. With this term being so generic, though, it makes it difficult to form any meaningful set of best practices based on the core principles. The solution? Classify dashboards based on type of data, usage, and purpose. From our experience, dashboards can be broken down into two main groups: snapshot dashboards and monitoring dashboards. Snapshot dashboards summarize a static dataset. The snapshot of time it represents is typically inherent in the data. For example, you can make a dashboard summarizing data from the 2020 census, or the results from an environmental study that you just conducted. They're often viewed once or maybe a few times. The purpose is to inform, explain, persuade, or enable the viewer to analyze the data. They can, and often do, tell a story. And color can be used in many different creative ways. Monitoring dashboards summarize data that is being updated. This could be every second, hour, day, or month. Dashboards are viewed on a recurring basis, as the viewer expects to have updated numbers each time they view it. They're used to inform, flag concerns, evaluate performance, provide a progress update, or enable the viewer to analyze the data. Typically, it's not for storytelling, as the data is ever-changing and it's difficult to do so. A muted color theme allows you to direct the viewer's eyes to what's important via color highlights. Common to both groups are the core principles of effective dashboards that we just looked at. Now, as we can see in the table, there are several different purposes under each group. So let's dig deeper into each one to better understand some techniques that might benefit your dashboard. Within the snapshot group, we've identified 4 different purposes, and these will influence the design. Information dashboards are unguided dashboards that summarize data in charts and other visualizations. They don't really seek to make an opinion or tell a story, and sometimes that's all you can do, or all you need to do. But this can leave the viewer to interpret complex charts and draw their own conclusions. Explanation dashboards highlight certain aspects of the data to explain something or tell a story. Persuasion dashboards use color and visualizations to evoke emotion and elicit a response. Analysis dashboards provide interactive filtering via selectors, charts, and/or maps, and they are not necessarily about telling a story or highlighting any insight. Rather, they're about looking up data, meeting some criteria, or slicing the data to find patterns or values. They may require some instruction and training on the data and how to use them. To better understand this group of snapshot dashboards, let's turn it over to Subin.
Thanks for the overview, Dave. Here is an informational dashboard based on the latest 2020 census data. From this dashboard, we can learn a few things. We can see that the population has seen an increasing trend over the past decade. We can also see that there is a bit more females than males, with the majority for both genders falling between the ages of 20 and 24. At its core, this dashboard simply informs the viewers by summarizing the characteristics of the city population, without doing too much in terms of drawing attention to certain parts of the data. It provides a snapshot associated with a specific time frame, but leaves the interpretation mostly up to the viewers themselves. But what if we wanted to highlight certain aspects of the data? For example, something interesting we see here is the overall increase in the city population. We can dig a little deeper to examine population changes. Here's an explanation dashboard that elaborates on the aspect of population change. To what degree has the population changed over the past decade? How about year over year? Which neighborhoods saw the highest increase in population? To better serve the purpose of an explanation dashboard, I have changed the map to a choropleth map showing a diverging color scheme, with the darker purple representing higher percent increase and darker green representing higher percent decrease in the past decade. Along with that, we also have some new changes here to look at. Here's an indicator to visualize exactly how much population changed in the past decade. The metric is reinforced with a background color that conditionally formats depending on whether we see a percent increase or decrease. In addition to this serial chart representing raw population totals over time, we've added another serial chart to visualize the degree of the change year over year. We saw an overall increase in the past decade, but this chart shows that the most significant increase was observed between 2014 and 2015. We've also combined the serial charts showing age distribution for each gender into one so that we can save on-screen real estate. Not only that, by placing the two charts side by side for comparison, we can see that there are more elderly females overall. Lastly, we have added some additional metrics in our list to display hidden information in our data, such as percent population change for each neighborhood, and how much of the neighborhood's population accounts for the city's total population. We have also added this visual indicator to further reinforce population change in each area. This dashboard communicates where we saw the highest population increase or decrease, and by how much. And this can be especially useful for explaining to organizations needing to decide if and where to plan its next program or initiative.
Thanks, Subin. That was a really great example of a snapshot dashboard transforming from being simply informational to explanatory. Now let's talk about the group of monitoring dashboards. The key difference is that the data behind the monitoring dashboard gets updated. As I said before, this could be many times per minute, hourly, daily, or monthly. And within this group, we've identified 5 different types of dashboards. Like with the Snapshot group, information dashboards are unguided dashboards that summarize data in charts and other visualizations. They don't flag issues, and they often use color to distinguish different aspects of the data. It is the simplest form of a monitoring dashboard. The purpose of many public dashboards is simply to provide a summary of the most recent metrics on a topic. Status dashboards provide the latest value of a metric along with flags for concerning events or data that need attention. They often show how a metric has changed in comparison to a previous period or over time. Performance dashboards are like a report card. They track performance measures, or KPI, and provide information on whether goals are being met. They're typically formed out of a strategic initiative put in place by either a company or organization, or municipality. For example, to get accredited, a fire department needs to meet a certain 90th percentile response time goal. They're long-term goals, and the measures are reviewed monthly, quarterly, or even annually. Progress dashboards highlight the percent of completion. They're affiliated with a program that has a clear start and end to it, along with a way to measure progress. They seek to answer the question of how far along is it, and is the program on track? Just like with the Snapshot group of dashboards, analysis dashboards are applicable to the monitoring group. Analysis dashboards provide interactive filtering via selectors, charts, and maps. They're not necessarily about flagging issues. Rather, they're about looking up data that meets some criteria or investigating a concern found in another monitoring dashboard. Okay. So that was a lot to take in. Let's jump over to Subin again to better understand this group of monitoring dashboards.
So remember this dashboard visualizing 311 request data? While this dashboard breaks down the data to a certain extent, it does fall short in some areas as a monitoring dashboard. There are 311 requests constantly flowing in through different systems, and the underlying dataset updates every minute or so to reflect the latest requests. This dashboard does not provide the level of information or detail that would be needed for an operations center or the mayor's office, as they would be looking for things like information for a particular time window, high priority requests highlighted, and maybe some additional context to the numbers, like have they changed or is there anything concerning or interesting about them? Both groups would also benefit from having an analysis-focused dashboard that allows further investigation into the data or to look up requests based on a set of criteria. This dashboard utilizes best practices of a status dashboard. We have a simple and subtle color scheme with very little visual noise. And we also have a dark theme that minimizes brightness, considering status dashboards are often wall-mounted for display. We can also see important numbers at a glance at the top left, which is where viewers' eyes start scanning. And we can see that the contents of the dashboard are based on a clear 24-hour time window. We also have elements of a real-time dashboard, as we have this live feed of requests coming in. And we also have the option to access the request details right at our fingertips if needed. To the right, we also have a sublist that draws out requests flagged as priority events, and these serial charts that visualize hourly volume of requests for the past 24 hours and daily volume for the past 14 days. They're both providing added context on how the volume compares over different dimensions of time. While this dashboard is highly effective in that it draws attention to areas of concern and focuses on a more relevant time frame for 311 operations management, we can certainly take this dashboard a step further using some advanced techniques. If you noticed, this dashboard doesn't call attention to any geographic insights, like which neighborhoods do we see a higher volume of requests coming in from? What we can do is create a bar chart showing the top 10 neighborhoods with the highest request volume. We can create a new chart based on this layer, set the categories to neighborhood, and get the top 10 neighborhoods in descending order. Let's change the transparency and color to be consistent with the other chart on our dashboard. And we're going to change the orientation to horizontal. So now we have a chart that shows the top 10 neighborhoods with the highest number of requests. But on second thought, maybe the number of requests per neighborhood is not as important as the number of requests per unit of the neighborhood's population. By accounting for the population size, we can get a relative measure of how each neighborhood is doing. So let's go ahead and update our chart. What we can do is use data expression to normalize the count of requests by the population size. Here's a data expression that calculates the number of requests per 1,000 people for each neighborhood. This time we're going to pull categories from features and pull this field called cases per population as the series. There it is. Now we have a chart that summarizes the top 10 neighborhoods with the most requests per 1,000 people. Another thing we can improve is this feed on the right. The current list provides key information such as the request ID, status, request type, category, and time. We can enhance the list so that it displays this information in a way that's easier to interpret and at a glance. So let's go into Configure and update our formatting expression. Here's an expression that conditionally formats each request item according to its status. It also calculates the difference between the time now and the time when the request was submitted. We will also enhance the list items. With that, let's hop over to the final dashboard with everything polished up. As you can see, using formatting expressions, we can dynamically render each request item in our feed, using colors to highlight its status, pointing out where the request was submitted, and converting the date of creation into the number of seconds, minutes, or hours elapsed. Now, this dashboard is not only showing temporal trends, but also spatial patterns in the 24-hour request volume. Additionally, it is using color in an effective way to draw attention to areas of concern, as well as displaying information that is regularly updated in an easy-to-interpret manner. Now let's check out another type of monitoring dashboard. This is another dashboard that utilizes best practices of a status dashboard, but focuses on a longer unit of time, 1 month. It is used to monitor slower moving trends than the real-time dashboard that we saw before. This monthly dashboard displays the recent month's request volume in the most prominent location at the top left. And again, there is a clearly defined time period visible in both the title and in the selector on the top right. We can quickly see how many requests are still open, what system they're coming in through, and which departments they should be reported to. On the left, there is a breakdown of requests by each category. We can select one to see monthly and weekly trends and its spatial distribution on the map. This is useful as each category is quite unique in nature and has its own set of influencing factors and patterns. But again, we can still improve a few things to turn this into a more intuitive and insightful dashboard. First, if you look carefully, this day of week chart is not sorted correctly. So let's go ahead and fix this. We can apply a custom sort order using data expressions. Here's a data expression that maps each weekday to an integer value and sorts it in an ascending order. Now we can pull categories from the day of week field, stagger the axis label, and change this into a line chart like before. There you go. Now let's talk about this chart. While this chart shows which categories saw the highest volume of requests last month, we have to click through each of the categories to see how this month's numbers compare to last month. If we want to visualize recent change, a list might actually be better suited than a chart. So we're going to create a new list to visualize this information. And to calculate monthly changes, we're going to use data expressions. Here is a data expression to calculate monthly changes in request volume by category. Now we're going to use conditional formatting to dynamically control how our list is rendered. Using the formatting expression, we can control how each category is rendered on the list, depending on whether it increased or decreased in volume compared to last month. But this comparison only considers volume from the previous month. What if there's a spike, but it is simply a recovery from a dip that preceded it? What if it's normal to fluctuate month to month based on historic data? Here's where we can take this analysis even further by improving our data expression. We're going to edit our data expression. And we're going to apply a mathematical formula developed under the field of statistical process control and analyze data from the past 18 months to determine whether the current month is indeed outside of normal ranges. To visualize our calculation, we're going to update our formatting expression. Here's an expression that uses green and red colors to draw attention to categories that saw significant dips or spikes in request volume. We will also enhance the list layout so that interesting or abnormal trends are highlighted. Or if the volume this month is above normal range. We will also apply the same method for the neighborhood chart. But to save time, let's jump over to the final dashboard. As you can see, we can even more quickly identify where request volumes have spiked or dipped. For instance, we can see that the number of construction issues is in fact decreasing significantly, and that graffiti issues in the recent month is indeed above normal range. Next, let's look at an analysis dashboard that complements the two status dashboards we looked at. Here is an analysis-style dashboard that is effective for looking up specific requests and investigating requests based on a specific set of criteria. It is simple and provides a few high-level metrics on the top right, such as the total number of requests, the percent of closed requests, and a 7-day rolling average chart. In fact, rather than focusing on visualizing the different dimensions of the data, it enables you to filter the large data set based on different dimensions. For instance, you can check how many building maintenance requests were submitted between today and around this time last year. This dashboard does not draw attention to areas of concern, but provides the means for you to draw your own analysis on the data by slicing through it. Now let's see how we can improve this dashboard. Since analysis dashboards primarily serve to provide interactive filtering through selectors to look up data, we want to make sure that the user experience is intuitive and is constructive to its purpose. Let's look at our side panel. Currently, all the selectors are presented as drop-downs, where you have to click through each one. Perhaps we want the users to filter a date range first and want to display the date selector in line so that it's always visible. Also, it would improve the ease of use if we provided both a defined list of date ranges and a calendar date picker. Lastly, we can add icons to different selectors to differentiate them. Now let's check out the improved dashboard that resolved some of the initial concerns. Here we have an analysis dashboard that follows best practices, also taking advantage of some of the latest enhancements to selectors. It is now using icons that speak to each filter topic, and it's providing both a list of predefined date ranges and a custom date picker. It is also showing the date selector expanded and visible by default to prompt users to filter the date first. Now let's say that the mayor's office wanted to investigate whether spikes in snow removal have typically occurred around the winter time over the years. This analysis dashboard provides the interactive filtering capabilities needed to drill into the data. Last but not least, we have another type of monitoring dashboard, a progress dashboard. Progress dashboards highlight the percent of completion typically of a program with a clear start and end date, along with a way to measure its progress. Here, we have a dashboard showing the progress of an LED streetlight upgrade program. We can quickly identify that the program is at 6% completion in the upper left gauge, and we have the actual counts below it, showing how many are left to complete. The green color is carried through in the map and in the chart to indicate completed items, making the dashboard intuitive and cohesive. This dashboard could be used by the program director, mayor's office, or even the public to discover how far along the program is in. One thing that is missing, however, is how far there is left to go. To add information about the program's duration, we can create a new indicator. We can add a simple formatting expression to find the difference between today and the end date. Next, we can calculate and show how many issues we need to average per day to stay within target of the completion date. To do that, we will simply duplicate this indicator since we use some of the same configuration settings. But this time, we will use a formatting expression to divide the numbers of incomplete issues by the number of weekdays left of the program. And below it, we will also add the calculation of the current average to add some context. Lastly, in addition to this chart showing the raw counts of issues completed per day, we can also show the percent completion at the end of each day to ensure that the program is on track. We can create a serial chart powered by data expressions to visualize cumulative percent completion. Here is an expression that divides the number of completed streetlights per day by the count of all streetlights, also taking weekends out of the equation. We'll pull categories from features and visualize percent complete. Now let's change the chart to a line chart so that it better serves its purpose as a progress chart. Now let's jump over to the final dashboard where everything is polished up. Now we not only have a clear indication of how far along we are in the program, but we can also see exactly how far there is left to go, and what targets we need to hit to reach program completion on time. Indicating how far along it is and whether the program is on track are important. For example, we might want to monitor the percent of total population vaccinated with a certain goal in mind. A progress dashboard would be especially useful so that the information is readily accessible and digestible. Now, I'm sure that was a lot of content, but I hope that you were able to see that while all of these are monitoring dashboards, each of them serve a unique purpose and audience. And as monitoring dashboards, these are common in that their data is always updating. They typically provide analysis of data with a defined time window, and they highlight areas that need attention effectively and intuitively. Back to you, Dave.
Thanks. Those were some great dashboards and techniques. It really shows the power of ArcGIS dashboards to grab your attention to where it's needed, make it easy to spot what's most important, and communicate that information that was previously hidden in the data. A final note on this. If you have an executive who wants to see a few of the most important visualizations from a status dashboard, performance dashboard, and/or progress dashboard, that's okay too. You can even include links out to these other dashboards for convenience. Now, let's cover a few more topics. In our examples, we primarily used green and red to indicate good and bad, respectively. Although commonly understood this way in many cultures, it's not unanimous. So make sure to use colors that are going to be understood by your audience, that can quickly be interpreted correctly or in the way you intend. Additionally, if you have colorblind users, they may not be able to distinguish red from green. As an alternative, orange and blue tones work well. If your dashboard users will need to open it on a mobile device, create another dashboard with a simple layout that looks good on the screen size. You can even embed each dashboard, the desktop and mobile, into a single app that loads the appropriate one. All this said, we're working on updating the application to have a responsive layout built in to one dashboard. For monitoring dashboards, remember that you may have to refine and adjust the dashboard over time. As more data accumulates, or as thresholds for metrics change, you may need to adjust them. Dashboards monitoring some aspect of a natural disaster or COVID-19, for example, will likely need to change as new questions need new answers, or the status of the situation changes. To address large amounts of traffic for publicly shared dashboards, ArcGIS Online utilizes a scalable architecture involving a content delivery network, or CDN, to optimize performance and reduce server load. A CDN works by caching responses to commonly requested resources. Within our documentation for ArcGIS dashboards, there's a page on building highly scalable dashboards. It provides guidelines for optimizing the layers in your dashboards and dashboard configuration options to ensure all generated network traffic is cached by the CDN. Following these guidelines will ensure that you do not negatively impact your organization. We continue to work to improve our utilization of this scalable architecture, and as such, the page continues to update. So visit it with each release. So we've covered a lot today, but if you remember one thing, remember, a good dashboard grabs your attention to where it's needed, communicates important information at a glance, and makes it easy to spot what's most important. If you'd like to get started with Arcade, advanced formatting, or data expressions, here's a list of resources. We want to thank you for joining us, and we value your feedback, so please click on the session survey link below this video. Now, let's open it up for questions.